It's been a while since my last update. I've been tending to make these update videos when I'm about to shift focuses for a while, but the 3D printer I got for Christmas has kept my focus for quite a while. So let me show you what I've been doing. I started out with basic PLA filament printing, and I was printing out D&D figures I found online. But tragedy, on one of my first prints on my first day, the printer head knocked off the printer bed plate, and the heated tip of the printer dug into the magnet underneath, melting it. This ended up being a rather common issue I found with the Cobra Pro 2. So make sure you're replacing the printer bed perfectly on the magnet and keep an eye out on the print during that first layer. This is just kind of good advice overall, is to really pay attention when that first layer is going down. Luckily, I was able to sand down the defect, re-level the printer bed, and continue. This figurine is from MZ4250's Patreon page. Go check him out. He's got a lot of cool free figurine STL files on his website. There's also this Gloomhaven bear I found on Cults 3D. That's my character. His name is Ramus. He's not a druid shapeshifter or anything. He's just a bear. And as you can see, I then colored them in. This one, I used a brown Sharpie to kind of middling success. It was too difficult to get in between some of those really tight corners. And there are still some blank spots, see, right here, that I couldn't really get into. It also came out a little streaky. See, there are darker and lighter spots. So I tried out acrylic paints next, which is the more traditional method, and that worked a lot better. You can get into the crevices real easy, and it's all relatively evenly colored. So we're going to stick with this method for finishing. Then it was time for me to try my hand at CAD. I have some experience with Autodesk 2012, so it's been a while. But the hyper-specific parts that I'm wanting to put on my table, they're not going to be found online. I'd have to make them myself. So I signed up for a free student subscription to Shaper 3D so I could design things on my iPad with an Apple Pencil. The first thing I designed was this heated blanket control panel that snaps to my bed frame. I was looking to see if I could make practical prints with PLA, and the answer is yes. With very precise measuring, I got a snug fit to my bed frame. You'll notice that the clip is, however, a little short. That appears to be a common quirk with the printer that needs to be accounted for, that holes tend to be too small. So a centimeter wide peg wouldn't fit into a centimeter wide hole, and that's something that needs to be accounted for in the design process. You can just make the hole a little bit larger and that'll compensate. I was amazed though at the gap the filament was able to cover. This is a 10 centimeter wide gap and it's just covering it. The end result is a little bit of stringiness on those first couple of layers, but since it's covered by the controller, it doesn't really matter aesthetically speaking. I also made this holder for my Heroescape tiles and this deck box that is currently holding my Mendicant Gore Guidelight deck. Unfortunately, one of the things I've learned since printing this is that prints that rely on friction in order to function, like this deck box, will tend to wear down rather quickly. It used to snap together real well since it has these indentations on both sides, but with repeated opening and closing, those indents have smoothed out and the parts don't stay together like they used to. If I were to do this again, I would incorporate magnets in some way, similar to what I did for the other deck box I built out of wood. Next, I wanted to push the limits of what I could print size-wise. First, I made an even bigger bear, seen here with a layer of primer paint applied. Then I made a basket for all the trash I was accumulating from the 3D printer. See, you get all this wasted filament and material that was used for support structures and brims, and it all gets very messy. So here's a 3D printed solution to my 3D printer problem. I was running low on my starter filament by this time, so I took the opportunity to try out a Pro 3D printer technique where you swap out the filament mid-print. It's not actually all that daunting so long as you're using a similar filament to the one that you started with the same kind of melting point. And you end up with this cool effect where the color changes mid print. And it's overall pretty rigid, even at the filament swap layer and even at a meager 15% infill. I used 15% infill because that was the default setting on the Anycubic app that can't be changed. But I knew that I would have to be able to crank that number up if I'm going to be making parts that may get dinged by a pinball. Denser parts are stronger parts. In order to adjust that, I would need to use a slicer program. I went with Ultimaker Cura. This free program also allows you to adjust things like print and bed temperatures, print speed, fan speed, infill pattern, and allows for a technique called ironing, where the printer head goes back and forth over a layer with little to no actual filament flowing in order to make a smoother top surface. I would adjust all these parameters in what turned out to be a very frustrating learning process, which was printing transparent parts. One of my more ambitious hopes here was to make custom playfield inserts, pieces that get hammered down into the playfield that the ball can roll over and lights can be placed underneath to illuminate various shots. The parts I'm making are by Mr. Peter on Thingiverse. I tried with transparent natural ABS filament, but was dissatisfied with the results. The prints were simply too cloudy, despite lots of fidgeting with the print settings on Cura. And the ABS also had a tendency to warp during printing, leading to very uneven surfaces. I thought I may be able to remove the surface blemishes by treating it with acetone, which did give it a more glossy look and certainly feels smoother to the touch, but it was still way too cloudy to use. After some research, I landed on Overture Transparent PETG filament, yet another type of material with its own thermal properties. But the trick to printing transparently is the same. Go hot and slow. No top or bottom layers. Infill 100% at a pattern of either concentric or lines, 220 degrees Celsius print temp, 80 degrees Celsius plate temp, speed of 25 millimeters per second, and fan set at 20%. With those settings, I was able to make these beauties. They're still not perfectly transparent, but they're good enough for light to get through, which is all I really need. I don't want people seeing the shape of the LEDs through the playfield anyway. I was considering myself a pretty pro printer at this point, so I decided to take on what will become the crown jewel of my pinball table, the hospital, which will house a hidden hole that leads to the nearby vertical up kicker. The hospital is composed of 6 parts. The inner tunnel, which is treated with a coat of paint to separate the light of the hospital from the tunnel so they can light independently of one another. Then there's the walls, which were printed in white, and I painted the lettering red with acrylic paint. The 3 window panes are transparent PETG, and then the roof was started with white PLA, then hot swapped mid-print with this silk blue PLA to distinguish the lettering for the hospital landing pad. I hot glued all the LEDs inside and super glued the printed pieces together, and now we have the big central target for the table. I followed that up with this custom-made defibrillator, which will also house an LED and will illuminate when hitting the jet bumpers. And it'll be like you're charging the defibrillator. I'm also going to attach the paddles to the main console here with some little springs, but I made a mistake with this print because I didn't make the holes big enough because the printer tends to print holes small, and I thought I already learned this lesson. Well, anyway, another thing I've been doing in preparation for my next undertaking is getting the stainless steel wire tunnels bent. These are tricky because the wires aren't bent all at the same angles. The wider turns use more material than the inside turns, so what I did was I bent small segments at a time. Slide these spacers on and just go turn by turn, wire by wire, until I got these. I'll be welding these together in the next video. The final piece I'll be demonstrating today, though, is the bottom drain hole display. This piece gives a little pizzazz to the drain. It's meant to emulate an old school aesthetic where they would take flat plastic pieces and screw them together, layered with spacers. I'm not using screws, I just superglued the layers together. And I had to design all this in a CAD program, which is distinctly different from a traditional drawing program, in that the shapes and curves are all rigidly defined, and the Shaper 3D program doesn't support freehand drawing, so this took a long time to make. It altogether came out to 3 layers for each the skull and the hand pieces, plus the background layer that had to be printed in 4 pieces. See, I cleverly hid the seams behind the skeleton pieces. This was a good project to use up that ABS that I didn't end up using earlier. See, you didn't even realize it was meant to be transparent, did you? But I like the way it came out regardless. The background was printed vertically as opposed to the more seemingly logical horizontal orientation. That's because the orientation gives the best sheen to the silk PLA. It's most obvious with these slingshot covers I printed standing upright so that these beautiful horizontal lines appeared. I bought a second roll of this aniline color changing filament because I was just so happy with this effect. I'm going to be using a lot more of this as I fill out the edges of the playfield, but that'll be another video. Stay subscribed to get more updates as they come out. Happy ballin'!